This is from HMH textbook lesson 14.2. What we were just doing with radicals was from 14.1, so we're still in the same module 14. Your EQ, how can you write a radical expression and an expression with a rational exponent? Sounds an awful lot like the EQ from 14.1, and it might be the EQ from 14.1. I can't guarantee you that I changed it. All right, learning goals. I can evaluate expressions with rational exponents and radicals too. I can rewrite expressions using rational exponents and radicals. All right, so radicals and exponents, they go together, hand in hand. And here's a little bit of review of what we have learned so far. Assignment number 9 in Delta Math, the one that we were finishing up in class yesterday. On simplify fractional exponents. So we had problems like this already, where maybe we had something like 320 to the 1/4 power, and we had to put it in simplest radical form. And in order to do that, we would convert it to radical form. We would rewrite the power as a radical. We have rules about that. So when you have this fractional exponent, the denominator becomes your index, or as they call it here, the root. It means the same thing. So I have the 4th root of 320. Because the numerator was 1, I didn't have to write the 1 anywhere. I could write it inside the radical sign. I could write it outside the radical sign. They would both work. And now we want to evaluate this radical. Since it's a 4th root, we want to see, is there 4 of some factor that I can pull out of the radical? And in fact, there is. Okay, there are 4 2's that I could pull out. So 2 to the 4th power is 16. 16 is a factor of 320. 16 times 20 is 320. So I can rewrite this 4th root as the 4th root of 16 times the 4th root of 20. It's kind of splitting it apart. That's all that's happening there. They're being separated. And then the 4th root of 16 is the 4th root of 2 to the 4th power. When you take the 4th root of something to the 4th power, or the 3rd root of something to the 3rd power, or the square root of something to the 2nd power, they're like inverse operations. They cancel each other out. And that's where this 2 comes from. Okay, because 16 is 2 to the 4th power. So you get 2. And then this just tags along because this is simplified, and then this is the final answer that you would have. All right, and so we're going to keep working with exponents and radicals. Now, this is under vocabulary because these are the properties of exponents that ideally you learned in 8th grade, but realistically, you probably didn't. Hemet Unified School District, the way that 8th grade teachers taught last year, this was saved for towards the end of the school year. And we didn't get to the end of the school year. So this may be the first time you're seeing these properties of exponents. And if it is, that's okay. All right, I'm going to explain each of them. They're basically like shortcuts. So when you're working with powers, bases and exponents, you know, the exponent tells you how many copies of the base. And so you can eventually do a lot of work to get to what you need to happen, or there's basically these shortcuts to get there quicker. So I'm going to explain each of them. A and B are real numbers, M and N are rational numbers. So we have the product of powers property. We're multiplying powers. And these two powers that we're multiplying have to have the same base. A is the common base. So if you multiply powers with the same base, you can just add the exponents. And the reason why this works is this example right here. I have 2 squared times 2 cubed. 2 is the common base. If I write this out, expand it out, 2 squared is 2 times 2. 2 cubed is 2 times 2 times 2. And then if I drop the parentheses, I have 5 copies of 2 here. So I have 2 to the 5th power. So instead of doing this step here of writing out all the copies of 2, there is this property or the shortcut that says, well, if it's the same base, just add those exponents. 2 plus 3 is 5. I could get here much quicker. The second one, quotient of powers property. We just looked at product of powers, and we're looking at quotient of powers. So we were multiplying powers, and now we're dividing powers. Again, we have the same base. A is the common base. Just like multiplication and division are inverse operations, addition and subtraction are inverse operations. And so when you are dividing powers with the same base, you can just keep that common base and subtract the exponents, the top exponent minus the bottom exponent on the denominator. Also, whenever you're working with division, you have to be careful that you are not dividing by 0. So that's why it says A should not be 0, because A is in the base. Make sure you don't divide by 0. An example of this working out, again, if I start with 2 to the 3rd power and 2 to the 2nd power, and I'm dividing these two powers. We have the common base of 2. So if I don't know the shortcut, what I might want to do is write out that 2 to the 3rd power is 2 times 2 times 2. 2 squared is 2 times 2. And then I can eliminate common factors until I'm just left with one copy of 2. 2 to the 1st power. All right, an easier way to get here is to do 2 to the 3rd power minus 2, and that is also 2 to the 1st power. We end up in the same place. One way is easier than the other way. One way is quicker, but you do have to memorize the rule to use this shortcut. Next one is power of a product, property. Okay, so that's when we have a product as the base. Power of a product. A times B is the base. The exponent is n. I can take this exponent n and bring it in to each factor inside the parentheses. A to the n times B to the n. To show you how this would also play out and be true, 2 times 3, all to the 2nd power. Well, this floating exponent of 2 means I have 2 copies of the base. I have 2 copies of 2 times 3. So I could write out 2 times 3, 2 times 3. And then because this is just multiplying factors, I could rearrange the order of the factors so that I put the 2 2's together and the 2 3's together. And then to rewrite each of these products as a power, 2 times 2 is 2 squared. 3 times 3 is 3 squared. So without having to do these intermediate steps, we can use this shortcut here. That's power of a product. Our next one, power of a quotient. Well, again, we have a power where inside we have 2 things that are not being multiplied now, but being divided. And we're still going to do what we did before. We brought that exponent into each factor. We're going to bring the exponent into the numerator and the exponent into the denominator. Also being careful that we're not dividing by 0. The example over here that shows how this works is if I had a division problem like 2 divided by 3 or a fraction, 2 divided by 3, and it's being squared. I know this to mean I have 2 copies of the base. So I have 2/3 times 2/3. And then using properties of multiplication, I can multiply my 2 factors of 2 in the numerator, multiply together my 2 factors of 3 in the denominator, and then rewrite 2 times 2 as 2 squared, 3 times 3 is 3 squared. So I went from this first step to the last step. Just using this rule here would be a lot quicker, but also it does work if you just work it out the long way. Power of a power property. This is the one we have seen more recently, working in delta math like we were yesterday, where we have a power raised to another power. When that happens, an exponent to an exponent, you multiply the exponents. To show that that does work, if I have 2 cubed, that quantity squared, I can think about 2 cubed as being the same as 2 times 2 times 2. I just expanded 2 cubed out. I still have my squared symbol tagging along. This Squared symbol means I have 2 copies of this. So I'm going to write 2 times 2 times 2 and write it again, 2 times 2 times 2. If I drop these parentheses, these are just all factors of the same 2, and there's 6 of them. So it's 2 to the 6th power. 6 is also what I get when I multiply 2 times 3. So instead of doing all this work, I could just use this rule here where I multiply the powers. All right, so we're going to be referencing this on some examples. This one we're going to do together. All right, so you want to make sure you have your Pear Deck open and you can see what I'm doing too, and you're going to work on this at the same time as me. All right, so simplify each expression. Assume all variables are positive. The reason why we want to assume all variables are positive is because if I go back to this, if I'm going to use any of these properties, okay, we don't want to ever divide by 0, so sometimes we need to make sure that we're not doing that. And if I say all variables are positive, that guarantees that we don't have any variable equal to 0. 0 is not positive. 0 is not negative. 0 is its own special thing. 0. Okay, so if we look here, we're going to be simplifying each expression. And we're starting with this expression right here. So, remember, so when you start using the pencil tool, you do want to resize it or you can get something that's like crazy big. So this is what we're starting with, and we want to simplify it, okay? Well, we do know this one rule that we've been using, right? We can rewrite it using a rational exponent. So, you know, before we were starting with something like this, where you had something to a fractional exponent, and then we were rewriting it as a radical expression, where 3 became the index and 9 became the exponent, but now we're just doing that backwards, right? So I'm taking this radical and putting it into this form. Okay, so that's something we've already learned how to do. I'm just doing it in the opposite order. Next, simplify the fraction in the exponent. All right, so the fraction in the exponent is just 9 divided by 3, right? That's what I have here, 9 divided by 3. That is just 3. Okay, so that simplifies it a little bit. Simplify the fraction in the exponent. Replace the 9/3 with 3. Next up here, we're going to use one of these special properties. We're going to use the power of a product property, which is the first one, product of powers property. So a to the m times a to the n is equal to a to the m plus n. Yeah. So just brought it in. No, that's not the same one. Power of a product. That's product of a power. Power of a product. That's this one. Sorry, my bad. I'm reading it backwards. Power of a product. So we don't have the same base. The exponent is coming into each piece. This is one when we have the same base. And that's why the 3 came into the x and the 3 came to the y. And then that's it. It's simplified. You're done. Okay, let's take a look at this one. So now we're starting with this. We're going to simplify the 5th root of x times, if you don't see an index, that's a square root, the square root of x. And so first step here says to rewrite using rational exponents. Okay, so just like we did up here, we're going backwards. They did this one for you. They took the square root of x and rewrote it as x to the 1/2 power. So what would this one be? The 5th root of x becomes x to the, there's a fraction in this box. What's my fraction going to be? Let's see if anyone has the fraction figured out yet. What fraction is going to go right there? How do I rewrite the 5th root of x? Got 15 of you trying this. Remember, you should all be in your Pear Deck working on this. What fraction will go right here in this box? When this was the square root of x, it became x to the 1/2 power. Now we have the 5th root of x, so this is x to the what? What goes in the box? This person has the correct numbers. They are not in the correct places yet. One over, good. Not 4. It's 1 over what? What is the root? The index becomes the denominator. The root becomes the denominator. There we go. 5, 1/5. Good. So the 5th root of x becomes x to the 1/5 power. The square root of x becomes x to the 1/2 power. Alrighty. Now it says the product of powers property. So we're using one of our properties again. Product of powers property. So let me go back to product of powers. Product of powers, that is the top one now. Okay, so a to the m times a to the n is equal to a to the m plus n. Well, x is the common base. And then these two exponents, 1/5 and 1/2, according to that rule, we're going to add them. We're going to add them. What is 1/5 plus 1/2? That's what's going to go in this next box. So we're going to simplify the exponent. We're going to have a new fraction here. You must remember how to add fractions. What is 1/5 plus 1/2? Oh, I just saw Adrian wrote 1/5 in the chat earlier when I was looking for 1/5. So thank you, Adrian. I just didn't glance there. Oh, okay. This is correct. I'm curious how they got their answer. So they went from 1/5 plus 1/2 and they got 0.7, which is true. Maybe they used a calculator. So that's one way to do it. You could use a calculator. Or maybe they did it a different way. I'm not really sure. I don't see their work, so I don't know what they did. I'm going to show you how to add these two fractions, though, on here using the method that you learned back in, oh gosh, I don't know, elementary school, 1/5. plus 1/2. I'm going to add fractions. I have to have a common denominator. So I'm going to rewrite both fractions to have a common denominator of 10, because 10 is the least common multiple of 5 and 2. And so if I change the denominator to 10 for 1/5, that means I multiplied 5 by 2, so I need to multiply 1 by 2. If I change 1/2 to something over 10, I multiplied 2 by 5 to get 10, so I need to multiply 1 by 5 to get 5. And now that I've done this, now I can add these fractions, because when you add fractions, you only add the numerators when you have a common denominator. 7/10. So here, you can write 7 over 10. 7/10. Okay, and now we're to the very last part here, which says to rewrite the expression in radical form. And so when we are simplifying an expression, to simplify an expression, do not leave fractional exponents. Do not leave fractional or rational exponents. Rational, yes, but fractional, no. All right, so this is not always simplified, so we just have to go back to using that other rule that we've been using since before we went on break, that a to the m over n is equal to the nth root of a to the m power. Right, this is still coming up, and that's what we're going to do here for this last step. X is the base, x is the radicand. 10 is the denominator, it becomes the index. 7 is the numerator, it becomes the exponent. All right. I'll give you a minute to catch up on that one, and then we're going to go to the next slide. So what I'm going to do here is put it on student paste, and I am going to go to the next slide. You may still be working on slide 4, okay, but we are going to start slide 5, which it says your turn, but I'm still going to help you with these, okay. Simplify each expression, assume all variables are positive. So we have the same directions once again. We're going to be simplifying and assuming all variables are positive. So we have some crazy expressions with exponents, x's and y's. There's a fraction in one. Some have radicals. They both have a radical, at least one radical. And so when you're trying to simplify one of these, you know, what did we do first over here on slide 4? Both times, the first step was to rewrite using rational exponents. Rewrite using rational exponents. So the first step over here is going to be to rewrite them using rational exponents. I'm going to go ahead and jump to the slide. All right, so we are simplifying, okay? And that first step is to rewrite with rational exponents. So first step, not orange. Rewrite with rational exponents. Okay, and that's what we did back here. Rewrite using rational exponents. We did that first. So we're going to do that first over here. This is actually like two pieces together, right? They're being multiplied. And then you don't see it. There's a multiplication dot here. And so as carefully as I can, I'm going to do this. what can I put here for this y? We have some of you that are already over here. You know, I'm just using that same rule that right here. A to the m over n is equal to the nth root of a to the m power. You may also write it, depending on your needs in the situation, as a inside the radical, and you can leave the m outside. So there's two different ways to do this. This depends on what you're trying to accomplish, but the one we're starting with is this one. So we started with this one. So this is just y. And you just leave it as y as one option. Because if I do write the fraction out, I get 4 over 4. Right? Because this 4 and this 4 gives me 4 over 4. 4 over 4 is just 1. So it does simplify to just 1, which is just y. All right. What are we going to do next? Let's see here. So one time we simplified the fraction in the exponent. One time we used a property. So I think now kind of differs on what we're going to do next. So for this one, let's just say, consistent with my pink. Okay. To use properties of exponents. Okay, so we rewrite with rational exponents. Now we can start using the properties of exponents. And we have a bunch of them. Okay. Say, see slide 3. Right. Slide 3. Yeah, slide 3. All right, so we have a power of a product property we're going to use because this 2 out here inside, these two things are being multiplied. So I can bring this 2 into each of these terms. So I'm going to rewrite this as x squared times 2. So I have, as my exponent is 2 times 2, times y, and this comes into here. And I'm also going to simplify this. 4 divided by 4. This step right here is kind of like where we simplify the fraction and the exponent. So you do want to do that also. So step 2 and step 3 might be concurrent. This kind of depends. So I'll just call this step 2 also, because you can do these at the same time. One's not more important than the other. Simplify any fractional exponent. So that's where this 4 divided by 4 just became 1. I am going to leave the 1 here because this is another rule. See how we have the same base and they're being multiplied? I can add these exponents and I can simplify this right here. So again, now I'm going back to simplifying 2 times 2. I'm simplifying any fractional exponents. Is that weird that they're both called number 2? Maybe if I just take out the 2 twice. I don't know. Let me do this. As needed, I suppose. Okay, so using the property of exponents and simplify any fractional exponents as needed. So right here, we're on to the next row. And so x, I'm simplifying, so I'm going to write this in blue. 2 times 2 is 4. And then multiplying that by y. So y to the second power and y to the first power. This, because they have the same base, this is actually 2 plus 1. All right. And so this is x to the 4th times y, 2 plus 1. So here again, I'm going to simplify these fractional exponents. 2 plus 1 is just 3. And now we're done. We're done with that one. So if I come over here and see how you guys are doing. I understand this is difficult to write on. You know, handwritten notes for this kind of stuff might be easier, just because, you know, you really do want to distinguish what the exponent is versus if it's just a regular number, okay? And so you have to be careful. Like doing something like this is misleading. Where are we at in time? I think I'm supposed to move on with you guys. So let's see. Period 6, 2:35. Oh yeah. All right. So real quick, I'm going to show you the last one. And I kind of went over on my time, but hopefully you're understanding this as we go. So rewrite with rational exponents. So this is going to be x. Okay, and then you have 4 and 8. Remember, it has to go in a certain order. 8 over 4. And then, again, x. And then 4 is the index. 6 is the exponent. The index is always the denominator. This is one of our exponent rules. All right. I'm not going to simplify these exponents yet because I need to subtract them, and they're already set up as fractions I can subtract. So 8 over 4 to minus 6 over 4. That's an 8. All right. Now I'm going to simplify the fractional exponents. Okay, so we can subtract these, which is actually 8 fourths minus 6 fourths. I have a common denominator, so it's just 8 minus 6, which is 2 over 4. And I am going to simplify this again. 2 over 4 is 1/2. I don't want to leave this here because it's not in simplest form. I want to get rid of, that should be the last step, get rid of any fractional exponents, and I'll add that in. So this is just going to be finally, it's the square root of x. What color here? There we go. Eliminate fractional exponents if necessary. Okay. So